We will now talk for a quick minute about something called the contrapositive, which is a basic rule that's very useful to simplify these statements. So we know that P implies Q is a conditional statement. In fact, we even know if we have P, Q, we have true, true, false, false, true, false. Messed that up. True, false, true, false. We know that P implies Q gives us the table true, false, true, true. And so now what we want to prove, what we want to show is that the contrapositive is equivalent. The contrapositive of a statement is equivalent to that statement. Or that P implying Q is the same thing as flipping the letters, switching it from P to Q to Q to P, and taking the negation. And if you do both of those things, we get an equivalent statement. So we need not Q, and then we'll need not P. So not Q is just going to be false, true, false, true. Not P is just going to be false, false, true, true. I get those by just negating these. And so now not Q implies not P is going to give us, remember we have, if it starts with a false, in a conditional, it's always a true statement. So we have a true right away. But then if it goes true, false, that's when we have our false. So we have true, false here. So this is going to be false. Then it starts with a false again, so it's true. And then when they're both true, it's also true. So we see that these two sections are the same. P implies Q is the same thing as not P implies not, as not Q implies not P. And the contrapositive is pretty useful in understanding a question. So let's take a minute and look at the contrapositive in real sentences. This always makes things a little easier to understand. So if we have the sentence, if you live in Los Angeles, then you live in California, well, we have living in Los Angeles as our P. That's very impossible to see. As our P. And we have living in California as our Q. So we have right now P implies Q. So let's flip it and negate and look for not Q implies not P. So you do not live in California. If you do not live in California, then you do not live in Los Angeles. And we see this is absolutely true. If you do not live in California, you don't live in Los Angeles. So we see that taking the contrapositive still gives us a true statement. Looking at the second piece, if the patient is not breathing, then the patient is dead. Which this might not always be true. I do want to acknowledge that this sentence is not 100% true, but it's worth seeing that the contrapositive is equivalent to it, whether it's true or not. So taking the contrapositive this time, we have not Q, or the patient is not dead. If the patient is not dead, then not P. The patient is breathing. And you'll see something cool here. We have in the first half of the statement, if the patient is not breathing, which means when we negate that over here, we do a not. We say the patient is not breathing, or the patient is breathing. We have a double negative hidden in there. And the third one, if all people obey the law, then prisons are not needed. Or, if prisons are needed, once again, we have the double negative, so we'd say if prisons are not needed, or if prisons are needed, then people are not obeying the law. Obeying the law. My pen is dying. And in our last case, taking the contrapositive here is simple. We're just going to take not the second half, not R, and it's going to imply not the first half, or not P and Q, which is the same thing as those nots canceling. So we have not R implies P and Q. And that is the contrapositive. So let's move forward a little bit. Let's solve a little bit of a more challenging truth table. So if I want to figure out what this one is, I want to figure out what that is, what I'm going to do, and this is pushing away from the contrapositive, but it's always good to have a lot of examples of these. I'm going to need what's inside of the parentheses here and what's inside of the parentheses here. I have to do what's in parentheses first, and then I can do the general and statement. So let's start with our P and Q. True, true, false, false, true, false, true, false. And then what do we need? We need both not P and not Q, so we might as well do those. Not P and not Q. Well, not P is going to be false, false, true, true. Not Q is going to be false, true, false, true. And the first one we need to know is what happens when P implies not Q. And remember, this is always going to be true unless we have a true implying a false, specifically. So let's do this one in green. And I'll look at P implies not Q. Oh, why did I switch away from green? P implies not Q. And we see that we have true implying false right as the first one, so that's going to be false. In the second one, we have true implies true, which is true. In the third piece, we have false implies false. Anytime it starts with a false, it's automatically going to default to true when you're doing a conditional. And we have a true again because it starts with false. Now we have to do the other one. The other one being not P or Q. Not P or Q. And notice these are the same things. These are the same things, but one has parentheses and one doesn't. And this is going to prove to us that the order of operations, even when you're dealing with logic statements, is very important. Doing things in parentheses first might change our answer. So now we have not P or Q. Remember, in an or statement, and this time we are dealing with not P or Q. When in an or statement, any time there is a true in either spot, we end up with it defaults to true. So for our first piece, we have true, false, so it's going to be true. For our second piece, we have false, false, so it's going to be false. Third piece, we're going to have a true, and fourth piece, we're going to have a true because there's at least a true in both of them. And lastly, we have our and. We have our first piece. If I say this is 1 and this is 2, then we have our 1 and 2, our whole half over here. And in an and statement, it's only true if both pieces are true. Well, this is true, this is true, this is false, this is false. So we end up with false, false, true, true. So we'll keep that. We'll keep our answer. And I'm going to erase all of this work because I already have it recorded. And then we can look at the right side. Now on the right side, we have a much easier problem. I still need not Q and not P, so I'll do that. Not P, not Q. On the right side, we have a much easier to solve problem because we're only going to have to work left to right. There are no parentheses. Not P is false, false, true, true. Not Q is false, true, false, true. And the first thing we need is P implies not Q. And you should always be pausing the video and trying to do these before me, because even if you think you're following along in math, a lot of the time, once you put pencil to paper, you start to see where your misunderstandings are. So P implies not Q. We're looking at the categories P and not Q. And a conditional is only false if we have true implying false, which we do have in the first case. Oh, I wrote a T. F. And then in the second case, we have true implying true, so it's true. Third and fourth, we have things starting with falses, so they're both going to be true. Because in a conditional, if it starts with a false, it defaults to true. Now we have that answer. We have this piece done. And then we have to just do and not P. This is just going to be that and not P. So let's see what that is. So now we're looking at the categories, not P, and our newest one. Just working left to right. Leave it in green. And so we have an and statement. So we have a false unless we have two trues. And we're doing the things in green. So we have two falses, so that's definitely false. Then we have a false true, so that's false. Then we have a true true, so that's true. And then we have a true true again, so that's true. So it looks like we might end up with the same answer. But we still have to do our or Q. So we're done up to here, and we still have to do the or Q. So let's look at, I'll switch to purple. We're looking at the Q category and our newest category. And in an or statement, as long as you have a true somewhere, it's going to default to true. So we have true, false and false is going to be false, but then here we have two true, so that's definitely true. And here we have two true, so that's definitely true. And you see that just the addition of parentheses, just the fact that we had parentheses, meant these two are not equivalent. We have two different answers here. Our first piece is it's true on the right side and it's false on the left side. So you really have to be careful with your parentheses and what order you do things in, just like in any other level of math. And our last part of this video that we're going to talk about is the DeMorgan's laws follow through set theory into logic. So you'll remember DeMorgan's laws from when we were learning the set theory. It's just that you can distribute a negation by putting it on both pieces and then flipping your sign. So we have an and here, so we switch to the negation of both pieces with an or there. And down here we have the same thing. We have an or here, and when we distribute our negation, it switches to an and. So it works the same as a logic statement. I'm actually going to have you prove DeMorgan's laws just using truth tables in our class, so I will stop here.